Hi, Avnish. This is our final design project for ECE 2001. So here we have the transmitting portion of the schematic, and here we have the receiving portion of the schematic. All right, for the design portion of the lab, we'll start with the mixer side. So the mixer side has two inputs. The first input is the microphone. Um, as you can see here, the microphone is powered off of 5 volts from the voltage divider over here. And the second input is the aux input. So the aux input is coming from the cable. Both of these inputs go through a capacitor each. So this is the aux capacitor and this is the microphone capacitor. And then through resistors. The resistors are at different levels. The mic resistor is actually lower to make the output of the mic higher when it goes through the op amp. These two resistors meet and go into the positive terminal of the op amp. And this op amp has a gain of around 500 with its negative feedback RF value resistors right here. The output of the op amp from node 1 goes directly to our bias T. So our bias T is right down here where this inductor and these capacitors meet. We had an issue where if we had low capacitance, it wouldn't allow any AC voltage to flow out of the bias T. But we fixed this by ramping up the op amp more and adding more capacitance. So we would have high enough AC voltage for the laser. Out of the bias T, we have it plugged directly into the laser. The bias T is not only the AC voltage input, but the DC as well. So we have 4.5 volts coming from the battery input side of things, and these two will meet having the AC peak-to-peak sine wave mixed with the DC for 4.5 volt bias. And that runs our laser. Right, you can get that. Now, for the receiver side of things, we have a much smaller circuit than the transmission side of things. We used a solar cell provided to us by one of the TAs. And we have one side of the solar cell grounded, and the other side is going through the op amp. This op amp has, once again, a gain of, I believe, 1,000, 500 to 1,000. So the input of the solar cell, which is very small AC voltage, will go through a capacitor to prevent DC backflow, and then it will go through our first RS resistor in our negative feedback op amp and into the op amp, and this is our RF resistor, and as you can see, it's a much higher value. And the output of this op amp goes directly into a capacitor, which feeds into the speaker. The op amp is set to 9 volts and 0 volts on the positive and negative terminals. This is just so it won't saturate, and that's the receiving side. Alright, so here we have the test portion of the lab. I currently have music going from my computer over here into the input aux for the circuit, and the AC voltage is going through the laser. Now over here, just for testing purposes, I have the circuit, and we should be able to hear music coming out of the speaker. So I'm going to shine this light onto the solar panel, and over here we can hear music coming out. It is very quiet. So you can hear the fast guitar work coming through the laser out of the speaker. It doesn't pick it up too well on the video, but it is certainly there. Now the next step is to test the microphone. So I'm stopping the music over on my computer, and I'm going to shine the light and speak into the microphone, and you should be able to hear it coming out the other side of the mic. It might be a little bit hard with the mic of the camera so close to me.